Hello friends, in the previous lecture we have got to know about the common ion effect as well as we have got to know that is what is the common ion effect or the dissociation of the weak acid in presence of its salt. And now we are going to discuss about what is the common ion effect on the dissociation of the weak base in its presence of its salt. So now let us talk about it. So now we are going to discuss about what is the common ion effect on the dissociation of the weak base, and since we know that the weak base is the one that we take it as commonly as that is NH4OH. So since it is a weak base, it will dissociate incompletely so as to form that is NH4 plus ion along with that of the OH minus ion. So suppose if a solution which consists of basically not only a weak base along with that of its salt, and that is basically the salt is basically NH4Cl. So now this NH4Cl, because it is a salt, it will dissociate completely so as to form that is NH4 plus ion along with that of the Cl minus ion. So this is what we have got over here. But what if we consider that the solution will only consisted of that is NH4OH? So if it would have been consisted of NH4OH, then it would have been given us the concentration of NH4 plus along with that of the OH minus ion. But since we are adding up the NH4Cl, obviously because it has been dissociated completely into NH4 plus along with that of the Cl minus, it will increase the concentration of the NH4 plus ions in the solution. And that only not will make the solution to be more in the terms of the concentration of NH4OH minus ion, but it will lead us to understand the principle known as Lee-Chatter's principle. And in that case, we have got to know that is whenever an equilibrium is maintained between a particular electrolyte so as to give its particular ion, or a stress has been produced because of the concentration has been increased in one side, and in this case the concentration of NH4 has been increased in one side. So that's the reason, because earlier what we have took is we have took that is 1 mole of NH4OH, but it is now been dissociating into NH4 plus along with that of the OH minus ion. But even here we could see that the NH4 plus is been the one which has in concentration, so that's the reason. And since it is dissociating completely, so therefore the only thing that we have in the solution is not only we have a weak base which has dissociated incompletely, but we will also get the concentration of NH4 plus along with that of the OH minus and the Cl minus. So in this case, basically the equilibrium that has been now been maintained, it will shift from right to left because it is following the Lee-Chatter's principle, and that's the reason that we could see that this NH4 plus will combine with that of the OH minus ion so as to produce back that is NH4OH. So therefore this is the reverse reaction that takes place over here. And that is how it is, because of the common ions that are being produced in the overall solution. And that's the reason that we could see that NH4OH is being produced, and meanwhile the concentration of the OH minus it goes on decreasing. Because earlier if we have used only that is NH4OH, then we could have observed OH minus ion, and since the OH minus ion concentration has been increasing, the pH value will increase. And that's the reason it would be called to be a basic solution. But since we are adding up the NH4Cl, and because of the common ion effect, the OH minus ion is been consumed by the NH4 plus ions, and meanwhile we could see that the concentration of the OH minus it goes on decreasing. And since the concentration of the OH minus goes on decreasing, obviously the pH value will also that is go on decreasing, and because it will form a basic solution. It used to be form a basic solution, but now since the pH value is going on decreasing, then obviously we could say that the OH minus has been consumed in the overall process, and we could say the pH is not only decreasing, but meanwhile we could say that the suppression of the dissociation is also being maintained, or is also being shown in this kind of process. So this is how the common ion effect of the dissociation of a weak base is, and because of the common ion effect we could suppress the dissociation of the weak base, in this case is ammonium hydroxide, and that is what the common ion effect plays a vital role in not only suppressing the the dissociation, but also in decreasing the pH value. And this is what I wanted to talk about. So that's it friends. So thank you friends for watching this video, and I hope you have liked this video and you have understood this video very clearly, and I hope you will share this video with your friends, and don't forget to subscribe to Ekeeda channel. Thank you so much.